We begin with a circle. This circle is going to be assumed to have radius 10 centimeters. If we move around this circle starting at the positive x-axis, if we move pi over 6 through an angle pi over 6, then we're going to be at a point whose x-coordinates is 10 centimeters times the cosine of pi over 6, and that's approximately 8.7 centimeters. Actually 10 times the square root of 3 over 2 centimeters. That approximates 8.7 centimeters. And the y-coordinate is going to be 10 centimeters times the cosine of pi over 3. The y-coordinate is going to be 10 centimeters times the sine of pi over 6, which is going to be 5 centimeters. Down here I've labeled the x-coordinate of this point, which occurs when the angle is pi over 3, and it's 10 centimeters times the cosine of pi over 3, which is 5 centimeters. And the y-coordinate of this point is 10 centimeters times the sine of pi over 3, and I've written cosine. This should be sine, not cosine. And that's about 8.7 centimeters. And that makes perfect sense that the coordinate of this point would be 8.75. If this is a circle of radius 10, here's 10 units. If this is 10, then this being 8.7 makes good sense. And if this is 10, then this looks like about 5. And similarly, the coordinates of this point are 5 and approximately 8.7. Now, as before, we're going to write a parametric equation. Our parameter is just going to be theta. So we're going to write parametric equations for x and y. X of theta is going to be 10 centimeters times the cosine of theta. Y of theta 10 centimeters times the sine of theta. X and y are simply the coordinates of these points. As we move through angle theta, x is just the x-coordinate of the point on the circle, y is just the y-coordinate of the point on the circle, so that this is a parameterization of motion around this circle. We let r of theta stand for our vector function. So our vector function's r of theta equals x of theta I plus y of theta times j. Again, x of theta is 10 centimeters times the cosine of theta. Y of theta is 10 centimeters times the sine of theta, so that our vector function can be written as so. It's very easy to write the derivative with respect to theta of our vector function. Everything in this term is a constant except for the cosine of theta. We know the derivative of the cosine of theta is the negative of the sine of theta. And similarly, everything in the j term is constant except sine of theta. And the derivative with respect to theta of sine of theta is the cosine of theta. So our derivative function is just negative 10 centimeters sine theta I plus 10 centimeters cosine theta times j.